Today we are going to look at lesson 5.5, solving equations by graphing. Now, if you look at the essential question, you're going to see some familiar words and some familiar things. Okay, it says, how can you use a system of linear equations to solve an equation with variables on both sides? Now, you think about this for a second. We have solved equations before when there was a variable on both sides. And do you remember the sentence or the acronym that we used to help us remember the order? There it is. What is it? Don't call me after midnight. So remember when we got to the M in me, it was move the variable. So we've seen equations like this before, where there was a variable on both sides, and so we moved one of the variables, and then we added or subtracted, and then we multiplied or divided to solve. However, the directions today are going to tell us to solve by graphing, and so everything has to change when we're supposed to solve these equations by graphing. Now, a system of linear equations. This is what we just tested over yesterday. When you have a system, how many equations are in a system of equations? There are two, okay? So we are going to be writing systems, plugging them into Desmos, and finding the point of intersection. So look at steps 1 through 3. How do we solve an equation with a variable on both sides? By graphing. Number 1, we set each expression equal to y. You say, Ms. Johnson, what's an expression? Or what expression are they talking about? Well, this is another word that you have heard and we have discussed, but it's been a very long time. What does an expression not have that an equation does have? Equal sign. So these are equations that you're going to be given, but you're going to be looking at the left side of the equal sign at the expression, and you're going to be looking at the right side of the equal sign for the other expression. So those are the expressions, the left side of the equal sign and the right side. You're going to set those expressions equal to y, which is going to create two equations. You're going to plug them into Desmos, you're going to copy them onto graph paper, and you're going to find the point of intersection. So there's only one new thing that I'm teaching you so far, and that is to set each expression equal to y. So let's look at example 1. It says solve the equation by graphing. Now, do you see what I'm talking about? If you just look at this problem, you're like, Ms. Johnson, I don't need to graph. Okay, I subtract 1/2 x from both sides, then I multiply both sides by the reciprocal, and I can have x solved for very quickly. And that is great, except for the fact that the directions say solve the equation by graphing. Okay, so we can't go the easy route. We've got to go the directions that are given to us. Okay, now step 1, we're supposed to take the expressions and set them equal to y. So who's brave enough to tell me what they think the first expression in this problem is? 1.5 x minus 3. You have an expression on the left and you have an expression on the right. So let's take the expression on the left first and set it equal to y. So y equals 1/2 x minus 3. Now, someone new, give me the second equation that we're going to write. What's the second expression that we're going to set equal to y? Y equals 2x. And now we have just created a system of equations. So pull your phones out, open up Desmos, and then lay your phones flat on your desk. Okay, we're going to make very sure that we are not doing anything on our phones today except Desmos. All right, now for those of you that don't have your phones, I don't have any iPads today, but I am going to put on the screen Desmos from my computer so you can follow along on my screen. The first equation we wrote was, help me out, y equals 1/2 x, and remember 1 divided by 2, the divided by sign will get you the fraction bar. So 1/2 x minus 2?
Minus 3.
Minus 3. And the second equation was y equals 2x. All right. Now, some of you are making graphing or transferring the graph from Desmos to your paper more difficult than you have to. All right. So let me show you how you should be doing this to make it quicker and to make it more efficient. Because some of you, I'm in the middle of grading your test, and your lines and your points are just, the points are so far up and down that they're off the graph and they're wrong for some reason, okay? So let me teach you how to do this more efficiently. First of all, find the point of intersection. What is the point of intersection on this graph?
-2, -4.
-2, -4. Remember, if we're not sure, we can plug it in and we can test it. It'll label it for us. Sure enough, that is the point of intersection. Now, we're going to follow the blue line. I want you to start at the point of intersection, and I want you to go up the blue line until you get to the next exact point. What's the next exact point that you see?
-1.
All right, now I'm still not zoomed in as much as I could to where I'm counting by ones. All right, so you're exactly right. When I do that, you see -1, -1.
-2.
Okay, but see, when we test it, we can see it's not on the line, so that will cause us to switch it. All right, very good. -1, -2 is the next exact point. Now, go back to the point of intersection. Jakari, run down the blue line. What's the next exact point you get to if you're going down the blue line? All right, -3, -6. We label it. Absolutely. Good job. All right, now let's do the red line. We've already got the point of intersection. So Joshua, if we run up the red line, what is the next exact point that we hit?
From 2 -4.
We're on the red line. We're at -2, -4. We're running up the red line to the next exact point. What do you see? 0, -3. If we check it, it is on the red line. All right, Timothy, go back to the point of intersection and go down the red line. What's the next exact point you hit? -4, -5. All right, very good. Now, are these the only points on the line? No, but this keeps your graphs smaller, okay? It keeps points on your graph. It causes less confusion, but these are the points. Now, make sure you're copying these points and these lines onto your paper. Make sure you are not just sitting there, all right? Because what's happening is you're not putting in your notes what we're putting on the board. And so when you go to study, you're not studying the right way because you don't have the right thing in your notes, all right? Every point should be up there. Every point is what up on that screen? Labeled. So every point in your notes should be labeled. And then what will Desmos never show us that we should actually be putting on our paper? Arrows, okay? We should all have arrows. These are full lines. These are full lines. So once you draw that line through all your points, make sure you put arrows on the end. All right, now we've got our graphs. So the next question is, what is the point of intersection? All right, because this is a system of equations, and the solution to a system of equations is the point of intersection. So what is the solution to this system? -2, -4. And I want everybody to write down that ordered pair, but I don't want anyone to box it in, because the solution is not the final answer this time. You say, what is the final answer? Well, I want everybody to go back to the original problem. If you go back to the original problem, you have the equation 1/2 x minus 3 equals 2x. What is the only variable in the original problem?
X.
So we are supposed to be solving for x, which means an ordered pair doesn't make sense as an answer. An answer that makes sense would be x equals. Well, where do you think we're going to get our value for x? In the ordered pair. So the point of intersection is necessary. We've got to find it, but for our final answer, we're only going to pull out the x coordinate. So for this problem, what does x equal? -2. And that is the final answer that we box in. You worked letter B with your partner. Let's start by writing down the equation. All right, Jakari, what equation did you guys write down first?
Y equals -4 plus 9.
Very good. Now, earlier today, I had a student who wrote down y equals 9x minus 4 because they wanted it in slope-intercept form. But does it really matter? No. Desmos is going to recognize it either way. All right, Maya, what was the second equation you guys wrote? Y equals, not 3x, -3x plus 2. All right, so these were our two equations. We took the left expression and we set it equal to y. We took the right expression and set it equal to y. And this created a system of equations. Now, you were supposed to plug that into Desmos, and hopefully you have been working on getting some points. All right, give me the point of intersection. Now, you had to zoom all the way in on this one because it got a little confusing if you weren't zoomed in enough. What is the point of intersection?
0.5.
Okay, 0.5, which of course when we write down our answer here in a minute, we're going to do a fraction. What fraction is represented by 0.5? A half, okay? But after that, you were able to find exact points. All right, so give me some of those points. You don't have to look at the screen. Look at your paper and tell me some of the points that you got on your graph. Timothy?
0, 2.
All right, you guys gave me the point of intersection at 0.5. You gave me 1, 5. You gave me 0, -4. You gave me 1, -1. And you gave me 0, 2. Now, were those the only points on the line? No. But those were the ones closest to the point of intersection. Now, let's talk about the point of intersection because it is the solution to our system. What is the solution to this system? 1/2, 1/2. Because remember, Ms. Johnson likes fractions. So 0.5 is the same thing as 1/2, 1/2. But Hayden, that is not our final answer. What is our final answer?
1/2.
Okay, but am I just writing down 1/2?
X equals 1/2.
X equals. Remember, if you go back to the original problem, the only variable in the original problem was x. So x is what we had to solve for. So we pull the x coordinate out of the point of intersection. So x equals 1/2 was the final answer. Now, this takes us into solving an absolute value equation by graphing. Now, I need you to go back with me quite a few chapters to absolute value equations and inequalities. Do you remember, and I believe it was chapter 1 and chapter 2, all right? In chapter 1, we solved absolute value equations by writing how many equations? How many equations did we have to write and solve when we were doing absolute value equations? 2. Remember, we would drop the bars and write down exactly what we saw. Then we would drop the bars and change the sign of the answer. Okay? Then we went into chapter 2 where we did absolute value inequalities. You remember how many inequalities we wrote? 2, right? We dropped the bars, wrote what we saw. Then we dropped the bars, we flipped the inequality symbol, and we changed the sign of the answer. Okay? So you have solved absolute value equations before. You've just not done it by graphing. All right? So let's look at the two systems that we are going to be writing. Now, if we're writing two different systems, how many equations are in one system? We've been solving systems of equations for the last 2 weeks. There's 2, right? And we're getting ready to write 2 different systems, which means we're going to be writing a total of how many equations? 4. All right? But let's look at system number 1. Again, system number 1 is super simple. We drop the absolute value bars. We set each expression equal to y. We plug into Desmos. We copy the graph on a graph paper, and we find the point of intersection. That is exactly what we just did in example 1, except we didn't have any bars to drop. Okay? But system 1 is dropping the bars and doing exactly what we did in example 1. We're going to set each expression equal to y. We're going to plug it into Desmos. We're going to copy the graph on a graph paper, and we're going to find the point of intersection. Now, here's where the change comes. System number 2, drop the absolute value bars, set the left equation equal to y, okay? And actually, is it going to be the left equation or the left expression? Yes, this should say expression. So once you cross that out, okay, we're going to set the left expression equal to y. Then look what it says. It says change the sign of each term on the right and set equal to y. So here's where the change comes. I want you to take your highlighter and I want you to highlight change the sign of each term on the right. Then it says plug into Desmos, copy graph on the graph paper, and find the point of intersection. So the second system is where the only change has to take place. Now, this is a lot of words, and some of you do really great with a lot of words. Some of you are like, Ms. Johnson, you lost me a long time ago. All right, so let me make this as simple as I can. Look at example 2. It says solve the equation by graphing, and it is clearly an absolute value problem. You'll also notice in your notes, you've been given 2 graphs for letter A. Do you see that in your notes? So one system's going to go below the first graph. The second system's going to go below the second graph. You're not putting all 4 lines on one graph, okay? Is everybody with me? So you're going to have to put your systems below each graph. Now, let's talk about the first system. The notes say drop the bars, set both expressions equal to y, plug in the Desmos, copy the graph onto your graph paper, and find the point of intersection. So we drop the bars. Who's brave enough to try to tell me what the first equation is going to be? All right, Haley. Y equals 2x plus 2. Perfect. You drop the bars and you set the left expression equal to y. So 2x plus 2. All right, what's the second expression going to be, Maya? Y equals x minus 2. And there is your first system. Now, for the second system, it says to drop the bars, and it says set the left expression equal to y. So if I do that, if I drop the bars and I set the left expression equal to y, what do I get? Y equals what? 2x plus 2. So look at what you notice. The first equations are going to be exactly the same. All right, so here's where I'm going to try to make it easier for you. After you write the first system, I want you to rewrite it. So we're going to rewrite y equals 2x plus 2 and y equals x minus 2. Because remember what we highlighted? You changed the sign of the expression on the right. What expression was on the right? So I want you to take your highlighter and I want you to highlight right there. That is the only spot that a change has to be made. We're supposed to change the signs. So instead of a positive x, we're going to change it to a what? Negative x. And instead of a negative 2, we're going to change it to a positive 2. And now we have written our second system. Plug the first system into Desmos. All right, what was the first equation of the first system? Y equals x minus 6.
2x plus 2.
What was it?
Y equals 2x plus 2.
I got ahead of myself. 2x plus 3.
2.
Okay. And for the second one, y equaled
X minus 2.
x minus 2. Okay. So we zoom in, we make sure we're counting by ones, we find that point of intersection. What is that point of intersection? -4, -6. Good. Give me a point above on the purple line. We follow the purple line. What's the next exact point that we see? -3, -4, or -5? -3, -5. Go from the point of intersection, go down the purple line. What's the next exact point that you see? So -5, -7. Good. Now let's go on the green line. Makai, if I start at the point of intersection and follow the green line, what's the next exact point that you see? -3, -4. Great. Go down from the point of intersection on the green line, and what's the next exact point that you see? -5, -8. There it is. Okay, so here are your points. Again, if you will just start at the point of intersection and go up the lines till you find a point and then down, you'll be finding these points a lot quicker than some of you are. Okay, some of you also have got to learn how to zoom in and out with your particular phone. All right, you might be zooming in and the X values are changing and not the Y. Okay, so you just got to mess around with your phone until you figure out how it zooms into counting by ones. All right, now, what is the point of intersection? -4, -6, okay? And we're going to come back to this in just a second, but let's go ahead and let's put the second system into the equation. All right, it was 2x plus 2 again, right? But then it became -x plus 2. So we move this around, and what is the point of intersection on this graph? All right, we've got 0, 2. Let's move along the green line. Give me an exact point on the green line. All right, I see 1, 4. All right, Seth, can you give me a point if I go from the point of intersection down the green line? What's the next exact point that I get to?
-1, 0.
Good, -1, 0. All right, and let's move over to the purple line. 0, 2. If we move up the purple line, what's the next exact point that we see? Negative 1, 3. All right, Anj, what if we move down the purple line? What's the next exact point we see? 1, 1. Good. Now again, these are not the only points on the line, but these are the quickest to find. If I will start at the point of intersection and I will move up to the next point, if I will move down to the next point, it will help me to move this along faster. All right? Now, what is the point of intersection on this one? All right, let's go back to the first system and write down our point of intersection. What did we say our point of intersection was for this first graph? Negative 4, negative 6. Now, that is not our final answer. What is our final answer? X equals negative 4. Again, we need the point of intersection to find the answer. All right? The only variable in the original problem was an x. So x is the only variable that we needed to solve for. Now, remember with all absolute value problems, we have to actually take our answer and plug it in to make sure it actually works. So let's do that. Let's plug it into the left side first. What is 2 times negative 4?
Negative 8.
Negative 8 plus 2?
Negative 4.
Negative 8 plus 2. Negative 6. What's the absolute value of negative 6?
6.
All right, let's plug it into the right side. What's negative 4 minus 2? Negative 6. And the absolute value of negative 6 is? 6. So this one works and we can keep it. Now, what was the point of intersection for this second system? 0, 2. Which Hayden makes our final answer what?
0.
Again, I can't just write 0. I have to identify the variable that I'm solving for. So x equals 0. Now, let's check it. What's 2 times 0? Plus 2. Absolute value of 2?
2.
What's the absolute value of 2?
No, 2.
Guys, the absolute value of any number, is it ever negative? No. So what is the absolute value of 2? 2. Plug it in to the right side. What is 0 minus 2? Negative 2. But what's the absolute value of negative 2? 2. So 2 does, in fact, equal 2, and we keep both of our answers. Now, let's work letter B. Again, it's an absolute value problem, so you've got 2 graphs. One system's going to go under one graph. The other system is going to go under the other graph. So work with your partner on letter B. What is the first system of equations that you got here, Riley? All right, you got y equals x minus 6 and... Very good. We got the first system. We got y equals x minus 6, and we got y equals negative x plus 4. Now, I told you, rewrite the exact same system, and where is the only place you had to make a change? You write the same exact system down, and where's the only place you have to make a change in this second system? Negative x plus 4. So it becomes... Instead of negative x plus 4, it became what for you guys?
X minus 4.
Good. It became positive x minus 4. Awesome. Let's talk through these problems in Desmos. You had y equals, here's x minus 6. I told you I got ahead of myself a little bit. And y equals, was it negative x plus 4? All right, so what was that point of intersection?
It was 5, negative 1.
Good, we got 5, negative 1. Now let's run along the red line. What's another exact point on the red line?
4, 0.
All right, here 4, 0. Good, that goes up the red line. Go down the red line. What do you got?
6, negative 2.
6, negative 2. Awesome, let's go to the black line. From the point of intersection, you go up and you see 6, 0. Guys are getting really good at this. All right, and then go down from the point of intersection, and what do you see?
4, negative 2.
4, negative 2. All right? Awesome. Don't forget, once you've drawn your lines through these, put your arrows on the ends. They all need arrows on the ends. Now let's go back and let's do the second system. The second system only changed In the second, right? The second equation became y equals x minus 4. So what do you see or notice about these two lines?
The lines don't intersect.
They are parallel. Is that going to change the fact that we have to draw them on our graph? No. We still got to draw the graphs, okay? So let's just label some points. I see 4, 0, okay? Because it's the x-intercept. What's another point on the red line? How about 5, 1? How about 3, negative 1? See 3, negative 1? All right. What about the black line?
7, 1.
All right. I hear 7, 1. I heard 6, 0. And I just need one more.
5, negative.
6. How about 5, negative 1? Okay, awesome. So really with parallel lines, it's not going to matter what points you choose. I would just find the 3 easiest points and I would plot them. All right, so here are those graphs. So let's talk about the solution to the first system. What was the solution to the first system? 5, negative 1. All right, but Treyon, what was the answer to that one? X equals 5 is the answer, okay? So the solution to the system was the ordered pair 5, negative 1. But again, the original problem only has an x in it. So we only need to solve for x, and so x equals 5. Now, let's test it. 5 minus 6. What's 5 minus 6 when we plug it into the left? What is the absolute value of negative 1? It works, okay? Because what's negative 5 plus 4? And what's the absolute value of negative 1? So 1 does, in fact, equal 1. Now, let's talk about parallel lines. What is the solution to this system? It's no solution, right? Okay, so let's write down above the graph, below the graph, wherever you're doing your writing. Let's write no solution, but don't plug it in, okay? Because we do actually have a solution or an answer to this problem. It's just instead of having 2 answers, we only have the 1. So what is the final answer to this problem? It's just x equals 5, okay? And that's okay, because if you think back to when we've done absolute value equations before, what happened if we plugged a number in and it didn't make a true statement? Remember, if we plugged the answer in and it did not make a true statement, do you remember what we did with that answer? What did we do with it? We crossed it out, right? It wasn't one of our answers. So that's what's happened here. It's okay that this one is no solution. Just make sure you don't box it in, because no solution is not the final answer. Okay, the final answer is x equals 5. And that is lesson 5.5.